Okay, so what we've done so far is to differentiate the function implicitly, but what we want to look for is dy dx. Okay, so what we've done so far is to group dy dx into one side. So we have x dy dx plus cos of y dy dx is equal to 1. We take the y to the other side minus y. Now we factorize dy dx out of the first, we get x, plus factorizing dy dx out of the second term, we have cos of y, and this is equal to 1 minus y. What do we do to get dy dx on one side? That is divide both sides by x plus cos y. So this is equal to 1 minus y all over x plus cos of y, and that gives us dy dx. Let's look at another example. When we have x squared plus y squared is equal to 25. This is an implicit function because when we take y to just one side, then we have y is equal to plus or minus square root of 25 minus x squared. This is difficult to differentiate, okay? So we leave the function in the form x squared plus y squared is equal to 25 and differentiate it implicitly. Okay, implicitly means differentiate x, indicate that you have differentiated an x with respect to an x. Differentiate y and indicate that you have differentiated a y with respect to an x. So we have x squared plus y squared is equal to 25. Differentiate x squared and you get 2x. Indicate that you have differentiated an x with respect to an x. Plus, you move on to the other term. Differentiating 2y, we get y squared, we get 2y. Indicate that you differentiated a y with respect to an x. And this is equal to, if you differentiate a constant, it's always equal to 0. Okay, the x dx is equal to 1. 1 times 2x is 2x plus 2y dy dx, and this is equal to 0. Okay, but we are looking for dy dx, so it means we need to make dy dx the subject. So we have 2y dy dx is equal to, you take the 2x to the other side and you get negative 2x. Divide both sides by 2y to get dy dx is equal to negative, the 2 crosses out the 2 and you have negative x over y. Alright, so I'll leave the third example, which is the x squared plus y squared minus 2x minus 6y plus 5 is equal to 0 for you to solve. And then I want you to go through the exercises in the slide as well, so that next week when we meet, you'll be submitting some. I'll let you know which ones that you'll be submitting and which ones that you'll not be submitting. Okay, so we've looked at functions, but why are we differentiating functions? Where are we going to apply these? There are so many areas or disciplines that you can apply differentiation. Okay, you can apply it in mathematics, you can apply in biology, economics, physics, so many disciplines, but we're looking at just a few. The first one I'll be considering is the application of differentiation in mathematics. Where do we apply derivatives? We apply derivatives when we want to find the tangent of a curve, when we want to find the slope, the normal, the equation of the normal, the gradient of the normal, so many stuff. Okay, so if you want to find the tangent of a line, if you want to find the slope of a line, then you apply differentiation. Then from there you can find the equation of another line that is in relation to the curve that you're finding the slope of. Alright, so let's look at a curve which is in the xy plane. Alright, if I'm able to draw a line that goes through only one point of the line, then the name given to that line is called the tangent line. Okay, because it goes through just one point of the line y is equal to f of x. Okay, and if I'm able to draw another line that is perpendicular to the line, the tangent line, then this is called the normal line. Okay, so that's 3 lines involved here. My original curve, which is y is equal to f of x, my tangent line, which goes through only one point in the curve, and then the normal line, which is perpendicular to the tangent line. So if I want to find the tangent of a certain curve, so y is equal to the certain curve that we are considering. To find the tangent of this curve, what do I need to do? You differentiate the line. Like I said before, the tangent, the derivative, the slope, the gradient, the differential, they all mean the same thing. It means differentiate the curve. So to find the tangent of this curve, it means differentiate the curve. And how do you differentiate the curve? It's finding dy dx, and this is equal to differentiating f of x gives you f prime of x. So if you've been asked to find the tangent of a curve, it means differentiate that curve. So if I differentiate this curve at this certain point, so at this point, let's call this x, let's call this y. If I differentiate the curve at this point, so x comma y, then what I'm finding is the slope of the tangent. If you differentiate the curve, you are getting the tangent. But if you differentiate the curve at a certain point, that is x comma y, then what you have found is the slope of the tangent. Okay, so let's call this m1. All right, an example is if y is equal to negative 4x plus 7, then if I differentiate this line dy dx, this is equal to negative 4. It means negative 4 is equal to the slope of the line or the tangent. Okay, another example, if y is equal to x squared plus 2x plus 7, all right, and then the line, one of the points, or if the tangent passes through the points negative 1 and 2, then it means that dy dx is equal to 2x plus 2, all right, but this is equal to the slope, all right, but to find the slope at this point, that is dy dx, finding the slope at the point negative 1 and 2 means finding the tangent at that point. Okay, so this is equal to my x is negative 1, so I have 2 into negative 1 plus 2, and this is equal to 0. So it means the slope or the tangent at negative 1, 2 is equal to 0. All right, and from there you can find the equation of the tangent line as well as the equation of the normal. All right, since the tangent is perpendicular to the normal, it means that if m1 is equal to the slope of tangent and m2 is equal to the slope of the normal, then m1 times m2 is equal to negative 1. That means since they are perpendicular, their slopes or their tangents are the negative reciprocals of each other. So if m1 is equal to 2, then m2 is equal to negative 1 over 2. If m1 is equal to negative 1 over 4, then m2 is equal to 4. Because they are perpendicular to each other, that means the angle between them is 90 degrees. Therefore, their slopes, the product of their slopes the product of their slope is equal to negative 1. However, if you have two lines that are parallel to each other, this is m1, m2, then because they are parallel, it means m1 is equal to m2. If you find the slope of this tangent, if you find the slope of this curve, it's the same as the slope of the other curve, because they are parallel. But if they are perpendicular, then it means the slope of this is the negative reciprocal of the slope of the other line. But because in this scenario here they are parallel, it means their slopes are equal. Okay, so an example over here, which is given that the slope of a tangent line passing through the point 2, 5 is -1. Okay, so it means I have a curve which is y is equal to f of x, and dy dx at the point 2, 5 is equal to -1. Find the equation of the tangent line, slope of normal, and then the equation of the normal line. All right, so we know the slope. If you know the slope, how do you find the equation of the line? Is it changing y over changing x is equals to the slope. All right, how do you find slope? Changing y over changing x. What is changing y? Changing y is y minus y1 over changing x is x minus x1. So this is equal to y minus, what is y1? 5 all over x minus my x1 is 2, and this is equal to the slope, which is -1. Okay, so cross multiplication, you have y minus 5 is equal to -x plus 2, and from here y is equal to -x plus 7, and this is the equation of tangent line. And how do you get the slope of the normal? Because the normal and the tangent line are perpendicular to each other, it means the slope of the normal is the negative reciprocal of the slope of the tangent. So if -1 is the slope of the tangent line, then slope of normal line is equal to the negative reciprocal of -1, which is +1. And so to find the equation of normal line, it means changing y over changing x, which is y minus y1 all over x minus x1 is equal to the gradient, which is 1. But my y1 is 5 all over x minus 2. This is equal to 1. Cross multiplication, and we have y minus 5. This is equal to x minus 2. Therefore, my y is equal to x plus 3. And this is the equation of normal. Okay.